Coming to the topic interprocess communication, as we know, we are having two types of processes. One is independent process, another one is cooperative process. Independent process in the sense both the process can do its work independently. That means there is no dependency between the process. Whereas cooperative process means one process, the output of one process will be the input for the next process. That is called cooperative process. So when the process comes as a cooperative process, there we have to enable some synchronization between the process. That is called inter-process communication. How we are enabling the communication between the process, that is called inter-process communication. So in inter-process communication, we can enable the inter-process communication in two different ways. One is we can go with a shared memory system. Another one is we can go with message passing system. So here I mentioned we have two types of process, independent and cooperative. So why we have to go for process cooperation in the sense for making the communication, like in order to pass the information and in order to speed up the computation. So for that reason only we go for inter-process communication. So here we are doing the communication in the sense we are sending the data as well as we are receiving the data. As I said before, we are having two models for that, shared memory system and message passing system. So here I have given the difference between the independent and cooperative process. So independent process, that the changes which is done in one process, that is not going to be affected and reflected in the other process, that is called independent process. Whereas cooperative in the sense, first process, if I did any changes in the first process, that will have a reflection on the next process. That means both the process are dependent on each other. So if it is independent process, then there is no message sharing will be happen between them, right? Whereas in cooperative process, both the process has to be synchronized, no? So we have to enable some communication. We have to enable some synchronization between the process. So here, if I go with cooperative process, so then I can achieve information sharing, computational speed up, modularity, and convenience. So here we have the diagram for interprocess communication using shared memory as well as message passing. The first diagram represents it is the shared memory, IPC using shared memory. That means a common memory will be shared among the process. That is called shared memory. And whereas message passing system, we are maintaining some message queues for uh, sending and receiving the data. So here we are going to elaborately we are going to see the things happened in IPC using shared memory system. Here we can go with three things. One is producer consumer problem, another one is bounded buffer and unbounded buffer. Producer consumer problem uses a common buffer. That buffer can be of two types, either it can be bounded or unbounded. Bounded in the sense there will be some limitations for that buffer, whereas unbounded has no fixed capacity for that. So in our shared memory system, here we have the diagram for that. So process A and B both are sharing a common memory, whereas that shared memory requires two or more process agree to remove the restrictions. So if in the producer consumer problem, the information that is consumed by the consumer producer produces a process now that will be consumed by the consumer. So we are having a common memory for that. So the producer can be allowed to store all the information in the buffer. Whenever the producer produces something, that should be consumed by the consumer. So here we have a structure for that. So here we have two process, producer and consumer. See, in between we are having a common buffer. So producer produces something, the data. I mean something here, something means the data, and that should be consumed by the consumer. So when we are having a common buffer, there we have a problem of synchronization. So the solution is we can go with a counter. So using a shared memory. So buffer will reside in a region of memory that is shared by the producer as well as consumer when the producer produces one item while the consumer is consuming another item. So that is what the solution which is given for the bounded buffer problem, that is producer consumer problem. Here we can go with two kinds of buffer. One is unbounded, another one is bounded. Unbounded buffer in the sense there is no limit for the buffer, whereas bounded buffer we are having some fixed limit. So here we can have two types of system calls wake up and sleep. When the producer produces something, when the buffer is getting full, then consumer has to wake, producer has to sleep. The consumer can consume the item. When there is a free space, then the producer can produce the item. Whereas when we have the buffer is empty, then there we can make the consumer to sleep because there is no item to consume. So in that place, producer have to produce. So consumer will wait until the producer release at least one item. So this is what the solution for the producer consumer problem. Buffer we have 0, bounded and unbounded.